So we will be creating the volumetric rays from the pieces that we created. So over here in our transform, let's grab our, let's see, I think this is the one. Okay, so these are all of the pieces, the high quality ones. I will Control C to copy this node and paste this over here where we will create our rays chain. And from these pieces, we are really only interested in the pieces that are close to the lightning. So from here, I will drop down on assemble and turn this back into packed primitives. So let's disable create name attribute and create packed primitives. So these are now points. If I were to drop down and add, let's delete geometry board kit points, and let's see how we can only get the pieces that are near the lightning. Let's go ahead and go up here at the top to where we have these curves and grab this, and let's bring it over here. So I will duplicate the object merge and place my curves here, and I will give these points a color of black. So set this to black and duplicate this color, and I will set this to white. And now I just want to do an attribute transfer between these. So drop down the attribute transfer and place this over here, and let's transfer the color. And for my conditions, if I now decrease the threshold, we are filtering only the pieces that we need. So from here I can say let's do a blast, and let's do at CD is bigger than 0. And for group type I will set this to points. And maybe I will turn on delete non-selected. So now we can get rid of this add node to work with our pieces. And for the attribute transfer, I can go ahead and just increase the threshold maybe. So we will spread this effect a little bit more. And I think this should be fine. And from this, let's unpack this so we have the geometry that we can work with. And now I want to get rid of all of the primitives that are not on the surface. So drop down a blast and let's select the inside here. And now we have filtered only the surface. And from here we can drop down a group node. And let's set this to be edges. Turn off base group and enable include by edges. And select this unshared edges option here, which will now turn all of our border edges into a group selection. And now we can use this group selection to create curves from these edges. And there is a very handy node that's called group, let's see, group to labs edge group to curve. So if I drop this down, and for this I will select the group that we just created, so group 5, we can see that we turn everything into a primitive, or rather a curve. So now we can use this to scatter points all over our surfaces. So drop down a scatter. Let's disable relax iterations and max points and just increase the point count here, and we will adjust this later. So what we want to do from these points is we will copy lines over all of these points and use that as a base for our volume. So here I will create a line, and let's make sure that this is oriented on the Z direction. So direction should be 0, 0 and 1. And I will drop this into a copy to points and place these as our template points. And now they are all facing the same direction because we don't have an N attribute. So let's create an attribute VOP here, and I will set this to be named set N. And inside I want to just create a parameter, and I will name this up. So set the label to up and make sure that this is a tree float. And if I plug this directly into my N, and I will go up, and let's just create a simple up vector. So this will be 0, 1 and 0. Now all of these are facing up. So instead of setting this normal attribute to a straight vector that points up, let's create maybe something a little bit more interesting. So I will go ahead and delete this parameter, and I will grab this position and I will subtract a value from this. And let's promote the second input here, and let's maybe rename this to offset. And make sure that this is a tree float vector. And I will plug the normalized version of this inside the N. So if I place this here, we are creating a vector that points from each point to the center point so far. So if I go up, If I now grab this vector offset and drag this value here in the middle, so the y value, I will drag this down, we can sort of imagine an invisible point that's going downwards in the y direction, and this vector on each point now is a vector that goes from this point, which is currently at negative 6.3, all the way up to all of the points, and it's creating this sort of direction here that's based around the center of the scene. So if I go back to my points, to my copy to points, we can further visualize this better maybe, and I will just decrease this. So you can see that maybe when I start at 0, all of these point straight out, and as I drag this down, they start to point more upwards. So basically all this means is that the ones in the center, so the rays in the center, will be more upwards, and as they go further out, they will have a more angled direction. And I also want these lines to be a little bit more spread out from the lining itself. So this will be a similar thing that we did when we set up that dir attribute that was used as a force in our .NET simulation. It's going to be pretty much the same thing, and let's see what I mean by this. Let's grab these curves again, and let's drag this over here and import it into our setN attribute VOP. So now we will access this from our op input to here, and let's drop down an XYZ distance and place the pose inside the P, and from this primitive I will drop down a primitive attribute, and so the prim goes inside the prim, and the prim UV goes to the UV, and also the file will point to our op input 2 as well. So we will grab the position from each curve, so where each of these points will land on the curve by using the closest point to surface, which is generated by this XYZ dist. And if I grab my position now and do another subtract here and subtract this P that we get from the curves, and let's also normalize this as well. And if I were to plug this in my N, we have now a vector that points from each point to the closest position on the curve. And I also want to flatten this on the y, so now before the normalize I will drop down a multiply and then promote this input 2 to a constant, and let's set this to a 3 float, 1, 0 and 1. And now what I can do is add this vector, so this new vector that we generated, we can add this to our original vector. So let's get rid of this normalize, let's drop down and add here. And let's also get rid of this normalize because we will normalize the final vector. Let's place this here. Or actually, we do need to keep the normalize for this. So my bad. Let's drop this inside the second input. So make sure that this vector is normalized. And I think also this vector should be normalized as well. So just ignore the whole normalize deleting part that I just did. So let's make sure that both of these vectors are normalized. And plug this inside the N, and also do a normalize here. And I want to scale how much this vector that we add will affect our original vector. And let's do another multiply here after the normalize, and let's promote the second input, and this will be spread add maybe, and go up a level. So now if I increase this, we should start seeing the vector spread. Also, one other thing I want to do is also scale this depending on how far our points are from the lining itself. So let's go back inside, and from this distance that the XYZ dist will create, I want to drop down a fit range and use this as a multiplier for the overall look as well. So if I plug this in here, I can reverse the destination min and max. So I'll set this min to 1 and the max to 0. And if I increase the source max, we can kind of see what this will do. And I think actually maybe we should not reverse this, so let's set this back to 0. And what this will result in is the vectors that are closest to the lining will not have the spread be affected that much. And we can increase and decrease the source min to further control the look. Alright, so we can see if I were to delete this wire and plug it back in, we can kind of see what this will do for us. So this will be good for the vector now.